Wow!
Hello, my dear friend Isaac. It has been a while since we last talked. In the months that have gone by, I have recently opened and found a box which contained a powerful piece of paper of knowledge with three equations hidden on it. The first of these is that the integral of cosine cubed is equal to the integral of cosine of x times 1 minus sine squared of x dx. The second of these is that the integral of u dv is equal to uv minus the integral of v du, which I affectionately call ultraviolet voodoo. The third of these is x squared plus a squared is x equals tangent of theta when doing something called trigonometric substitution. Rather than dryly explaining them to you, I would prefer to give you an illustrious example of them in action in real life. Recently, I have found out that I can use these equations in order to integrate the equation of the rate of change of the paper in my garbage can modeled by 1 over the square root of x squared plus 1 plus 1.3x times cosine of x plus cosine cubed of x in order to figure out the amount of paper in my garbage can, starting with 20 pieces at any given time. So, Isaac, the first thing we need to do is take our equation and integrate it so we can get the total amount of displacement of the paper in the garbage can over any amount of time from A to B, and we add 20 to that to get the total amount of paper in the garbage can. And we split up the integral to make it easier so we can have three different parts with each part corresponding to each equation on the sheet of knowledge that I found in the treasure box. And let's start with the one on the right, and we'll break cosine cubed up into cosine of x times 1 minus sine x squared, because 1 minus sine of x squared is equal to cosine of x squared by the Pythagorean identity. And then we just make u be sine of x and dx be du over cosine of x, which then cancels out a cosine and gives us that. And then we integrate that using the power rule to get that. And we can plug a to b in. And let's start on the next one, which is the second to last. And we'll use Lyate in order to figure out which thing should be the v and the u in this scenario. And because cosine is closer to the end of Lyate, it's going to be the v. And because 1.3x is closer to the beginning of Lyate, it'll be the u. So we substitute the u and v into the equation into the second equation that I found on the sheet of knowledge, and we get that, and then we just integrate the thing in the integral to get that from a to b. And now let's start with the first one. And for this, we'll have to use something called trigonometric substitution, which we substitute x equals tangent of theta in for x because it's x squared plus 1 under the square root. And we'll have dx over d theta equals secant squared of theta, and we'll multiply the d theta over to get dx equals secant squared of theta times d theta, and then we'll plug those in and substitute secant squared of theta d theta in for dx to get that. And then we'll see that tangent squared plus 1 is basically the same as secant squared by a trigonometric identity, and we'll put that in, and then we'll take the square root of secant squared to get secant, we'll divide to get secant in the entire integral, and then we'll take the integral of secant, which I had to Google, and to get natural log of secant x plus tangent of x from a to b. And finally, we combine the pieces of the original integral and add 20 and substitute sine of x for u to get 20 plus natural log of secant x plus tangent of x plus 1.3x sine of x plus 1.3 cosine of x plus sine of x minus 1 over 3 sine of x cubed from a to b, and we'll plug in whatever starting amount, like whatever starting time we want for a and whatever ending time we want for b to find out the total amount of paper that in those time intervals. And we would usually want to start with a being 0